This is Pre-Calculus Onramps, Unit 8, worksheet on L'Hopital's rule, which some people call it Bernoulli's rule. Bernoulli was under contract with L'Hopital to teach or tutor L'Hopital's calculus, and part of that contract said any discovery that Bernoulli made, L'Hopital could use and put his name on. So Bernoulli discovered it, L'Hopital used it, as the contract stated. So we know it as L'Hopital's rule. Some people say Le Hospital's rule, but some people call it Bernoulli's rule. But anyway, what it says is if I initially look at the limit and I plug in, like in this case, x is 0, and it's an indeterminate form. An indeterminate form is either plus or minus infinity over infinity or 0 over 0. Then I can try taking the derivative of the top and the derivative of the bottom. They must be differentiable. The derivative of the bottom cannot equal 0, or you'd have division by 0. I can take the derivative of each one and then try the limit and see what happens. And a lot of times, now you'll get a value. So let's check this one out. As x approaches 0, 7 times 0 is 0, so the sign of 0 is 0. 0. Why is this moving around like that? Divided by 4 times 0 is 0, sign of 0 is 0, indeterminate form. Let's try L'Hopital's rule. I'll take the derivative of top and bottom. And check this out. I have to use the chain rule because there's an inside function, outside function. So I'm taking the derivative. The derivative of 7x is 7 times the derivative of sine of 7x is cosine. I guess I'll just write it like this, cosine 7x. And likewise, derivative of the inside is 4, derivative of the outside is cosine 4x. Now let me try plugging in 0 and see what happens. 7 times 0 is 0. The cosine of 0 is 1. 7 times 1 is 7. Divided by cosine of 0 is 1. 4 times 1 is 4. 7 fourths. Ba-ba! There is the limit of that by using L'Hopital's rule. This one on top, the answer sheet shows it. There's a key posted, and it shows it being worked with L'Hopital's rule. But let's check out if this is an indeterminate form. What is the cosine of infinity? Cosine and sine, by the way, both oscillate between 1 and negative 1. I put a minus. It should be 1 and negative 1. So it doesn't go to infinity. This is an oscillating. And then if x is infinity, this would be something oscillating over infinity. That is not an indeterminate form. Cannot use L'Hopital's rule here. What I actually have to use is the squeeze theorem, which I'll show that, even though it's not part of this course. Cosine x goes from negative 1, less than or equal to cosine x, less than equal to 1. Now, if I can take a limit and find the limit of this and the limit of that, and they're both the same thing, then the limit of what's between them must be the same thing. So since I'm taking limit as x goes to infinity, I'm going to divide by the highest power of x, which is x to the first. And negative 1 over x to the first is 0 as x goes to infinity. 1 over x to the first, or 1 over x as x goes to infinity is 0. So that's the limit. So the limit of cosine x must also be 0. But I can't get that from L'Hopital's rule. That comes from the squeeze theorem. Let me do one more here. Limit as x goes to 1. I'm going to try plugging in 1 and see what happens. 3 times 1 cubed is 3. Minus 4 times 1 squared is minus 4. Plus 1. 3 minus 4 plus 1 is 0. Okay, let me see if the bottom. 9 times 1 cubed is 9. Minus 2 times 1 squared is 2. Minus 6 times 1. Well, that's 9 minus 8, which is 1. 0 over 1 is 0. I cannot use L'Hopital's rule because it's not an indeterminate form, nor do I need it. It just comes out to 0. So that's a couple of problems on L'Hopital's rule. And I've told students to check this one, number 4, with the teacher, because L'Hopital's rule does not apply, but the answer sheet where they're worked out shows it applying, and it does not apply.